Analysis of singly reinforced beams. Types of RCC sections. The following are the different types of reinforced cement concrete section. Your RCC beam section may be any one of the following types: balanced section, under reinforced section, or over reinforced section. First, balanced section. We call an RCC beam section as a balanced section if the yielding of steel and crushing of concrete occurs simultaneously. We know that the concrete is effective only in the compression side, and we have steel on the tension side of the RCC beam. We call an RCC beam as a balanced section when crushing of concrete occurs on the extreme compression fiber and yielding of steel occurs on the tension side. So see this figure. It is the design stress strain diagram for concrete as well as steel. When we say that crushing of concrete occurs, the strain in concrete must have reached 0.0035. When we say the steel has yielded, then the strain in steel must have reached 0.87 Fy by Es plus 0.002. So that is what is given here. When concrete and steel reaches the ultimate stress simultaneously, we give the strain of concrete as equal to 0.0035 and we give the strain in steel on the tension side equal to 0.87 Fy by Es plus 0.002. Next we discuss about under reinforced section. Under reinforced section is a beam cross section at which the steel reaches the ultimate stress well before the concrete reaches its failure. So here yielding of steel occurs first and concrete reaches crushing failure only later. So in other terms we can say when concrete reaches the ultimate compressive strain of 0.0035, the steel might have yielded already. That is, the strain in steel must have exceeded this value. The strain in steel has exceeded this value 0.87 Fy by Es plus 0.002. So that is what is explained here. Concrete, while it reaches the ultimate compressive strain of 0.0035, the steel has already yielded and the strain in steel must have exceeded 0.87 Fy by Es plus 0.002. Now coming to the next case of reinforced concrete section, that is over reinforced section. When concrete reaches ultimate stress first, that is, the crushing of concrete occurs first well before yielding of steel happens. That is, the steel might not even have reached the yield strain. The strain in steel might be somewhere here or somewhere here. It may not have reached the yield strain 0.87 Fy by Es plus 0.002. So that is when we say the concrete strain, the strain in concrete is equal to 0.0035 and the strain in steel on the tension side is less than this value. So epsilon st is less than 0.87 Fy by Es plus 0.002. And we must understand the difference between all the three. In the first case, in balanced section, crushing of concrete and yielding of steel is happening simultaneously. So just imagine when steel fails at the same time as crushing of concrete occurs, what happens? The user or the occupant will not get adequate time to escape. So yielding of steel and crushing of concrete is generally not a preferred section of RCC beam. Now coming to under reinforced section, we discussed that yielding of steel occurs first and crushing of concrete occurs very later. So what does it mean? The yielding of steel occurring first will result in large tensile cracks and increased curvatures in the beam. So the user of the beam actually sees and perceives large deflections in the structure, which will give adequate warning to the user about the failure. Hence, this is the most preferred concrete section. We call such type of failures as ductile failures. Now about the over reinforced section, we learned that crushing of concrete occurs first and steel may not even have yielded. So when steel has not yielded but crushing of concrete occurs first, what does it mean? It is not even giving any warning signals to the user or the occupant, and it is a sudden failure. The steel has not yielded and is not giving any warning to the user. Suddenly the concrete section is crushing down, and this is very dangerous, and we call such a type of failure as a brittle failure. It is generally catastrophic or disastrous in nature. None of the beam sections or slab sections should become a over reinforced section. Over reinforced section is never going to be designed. We should never have an over reinforced section. Now the above three kinds of sections are briefly summarized in the figure shown here. Here you can see that the strain distribution in the RCC beam is plotted for all the three types of sections. The balanced section is shown by the solid line, under reinforced section by the dashed line, and over reinforced section by the chain line. You see, the solid line represents the balanced section. We already said the concrete reaches its ultimate strain of 0.0035 in case of balanced section, and you observe that at the level of steel, at the level of the reinforcement strain in steel, it is 0.87 Fy by Es plus 0.002. So that is typically a balanced section. And the strain distribution, we already discussed that strain distribution is always a straight line. It is a linear distribution. Now coming to the under reinforced section, we said that when the concrete fails, when the concrete reaches its ultimate strain, the steel might have already yielded and the strain in steel might have already exceeded this epsilon st value, that is 0.87 Fy by Es plus 0.002 might have already been exceeded by the steel. So such a section we call as the under reinforced section. So this represents the typical strain distribution for a under reinforced section, and Generally, under reinforced section is the most preferred section. Now coming to the over reinforced section, you observe that the concrete has reached its ultimate strain, but steel has not reached the yield strain. So the concrete fails first. So this is very much characteristic of the over reinforced section, and this represents the strain distribution for over reinforced section. So the same figure itself is showing all the three types of concrete sections in terms of its strain distribution. Now let us call the depth of neutral axis as the distance from the extreme compression fiber to the neutral axis. The neutral axis is somewhere here, where the strain distribution changes from compressive strain to tensile strain, and we call the depth of neutral axis equal to XU max in case of balanced section. You see the balanced section, this solid line, the solid line is changing from the compression side to the tension side at this point, and this distance is what is represented as XU max. This is the depth of neutral axis for a balanced section. Similarly, you can find the depth of neutral axis for the other types of sections, for under reinforced section and for over reinforced section. Here, in case of under reinforced section, the depth of neutral axis is less than XU max. So we say XU is less than XU max in case of under reinforced section. So in case of under reinforced section, the depth of neutral axis is less than XU max, where XU max is the depth of neutral axis for a balanced section. Similarly, we can say the depth of neutral axis for the over reinforced section. For over reinforced section, you observe this figure. The depth of neutral axis from the extreme compression fiber is greater than XU max. So we write it as XU is greater than XU max. So this is another way by which we differentiate balanced section from under reinforced section and over reinforced section. If the depth of neutral axis for balanced section is XU max, then the corresponding depth of neutral axis for under reinforced section is less than XU max, and for over reinforced section is greater than XU max.